Hybrid energy conservation, storing and reusing heat. A practical demonstration using sodium acetate trihydrate as a heat battery. I am Kimaya Sharma from class 9K. I am deeply interested in energy conservation, real world pollution control, and sustainability projects to help the nation reduce dependence on external countries for fuel. This project matters to me as India spends large foreign currency on importing fuels. Industries waste huge amount of heat that they consume and then consume more energy for cooling. I want to show how chemistry can conserve energy in two directions by reusing the heat and reducing cooling requirements. The problem in industries today is that a large amount of heat energy is lost to the surroundings as industries waste 20 to 50% of the energy that they consume. Massive losses occur via hot exhaust gases and hot cooling water, and the wasted heat disperses into the surroundings instead of doing useful work. The aim of the project is to demonstrate a hybrid thermochemical energy model that recovers lost heat for reuse and reduces energy consumption for cooling. Energy cannot be created or destroyed. It can only transfer or transform between systems. Wasted heat is not destroyed, it simply spreads into the surroundings. And if captured or redirected, it can prevent energy wasted in two ways by reusing heat when required and reducing the energy requirements for cooling. Experiment 1, Sodium acetate trihydrate as heat storage and reuse. The apparatus and setup for this experiment is two beakers, distilled water, sodium acetate trihydrate, and this is the dissolved form, a digital thermometer of probe type, a glass rod, a water bath, and a digital weighing scale. Sata is heated until dissolved completely. It absorbs heat, which is an endothermic reaction. Then the clear hot solution is allowed to cool undisturbed, and the heat remains stored in a supercooled state. Then crystallization is triggered. The stored heat is released sharply, which is an exothermic temperature rise. This proves conservation, as the heat absorbed earlier as latent heat was not destroyed. It was simply stored and then released when required. SAT thermochemical explanation. Melting the dissolution phase. When SAT is heated, the crystalline lattice structure breaks down and the hydrogen molecules are released from the trihydrate crystal network. This breaking of bonds requires energy from the surroundings, resulting in endothermic heat. On gradual cooling without disturbance, crystallization does not start immediately, and the liquid remains below its freezing temperature as a metastable supercooled state. The absorbed heat is stored as potential energy in a molecular configuration. In the recrystallization phase, a small disturbance such as seeding, tapping, or triggering initiates crystal nucleation. Here we will be using seeding. The crystal lattice reforms and new intermolecular bonds are created. This formation of bonds releases energy as heat, resulting in rapid temperature rise. This is the recrystallization phase. As you can see, I have dropped a seed crystal inside the melted sodium acetate, and now the crystals are slowly reforming. Let us now check the temperature. As you can see, the temperature is currently 30 degrees and is constantly increasing. 100 gram of sodium acetate trihydrate releases about 30 kilojoule of energy, nearly equal to 100 watts of thermal power over 5 minutes. In ideal insulated space, this heat can raise the temperature of 3 meter cube of air from 21 degrees Celsius to around 30 degrees Celsius, which demonstrates that as an effective localized heat storage and controlled release mechanism. Industrial possibilities for using satellite systems include chemical reactors where it can provide startup for heating. In food storage and transport, it can maintain the warm packaging, and in battery and fuel cell cooling, it can pre-warm the battery systems. From a fermentation, it can maintain temperature for fermentation. And in industrial furnaces, it can recover and reuse the lost heat energy, and boilers and heat exchangers can store discharged heat for reuse. Thank you for your time and attention. I express my gratitude to Raman Award Foundation, my school Delhi Public School Bangalore East, my mentor teacher Ms. Arul, and my parents for their support and encouragement. Thank you.